Hi friends, thanks for joining me. I want to do a quick video on the Builder project. The Builder project is something that I released a few days ago now, and all the reception was somewhat interesting. I got a lot of people asking me why, what's the point of it all, etc. Which tells me I'm onto something here. So I thought I'd do a small introduction to the project, as well as share my train of thought and my kind of a journey, and I'm doing air quotes here, that led me to building this Builder project. So what is Builder? Builder is a preprocessor for the R programming language. In essence, I've been meaning to, tinker around the R programming language for a long time, because I use it a lot because of a lot of, So a lot of the tools that I have built in the past are built in R. People somewhat know me for my R work, and I get a lot of R work done for say professionally, for a living. R kind of feeds me. And with this, as much as I appreciate the language, I find a lot of shortcomings that I often think about fixing. And well, there are many facets to that, of course. One is I'm not skilled enough to just go into source code of R and just fix stuff. This is not what I mean to do. Second, even if I could, it kind of wouldn't be, I don't think it would be, whatever I would do would end up being merged. So I can show you maybe something here. That's the website for vapor.run. You can go to that address. That was a project I did quite some time ago. And I had very limited success. Essentially, it was attempting to be a typed superset of R. I got corrected somewhere in the issues. I think it's technically not a superset. For a superset, you'd have to be able to handle, that is, lex, parse, transpile, pure R code, which I don't. Vapor is a brand new language. And the idea here was really to bring types into the equation. So I can show you if I scroll down, there's an example here of Vapor code. You create your own type. It looks very much like Go. An object is just a named list in R. Create a function that's going to return a person with a given name. I can then have a generic called setAge to just set that integer. But as you can see, I have types essentially. I have custom types, I have built-in types. And essentially I have my Vapor code that I can then run Vapor, transpile to R code, and that's what it would produce. Like I said, it had limited success, as in, well, first it was an interesting journey, as in I built everything from scratch using Go, standard library, the Lexa, the parser, the transpiler, all of that stuff. It was pretty fun. But in and of itself, I don't know, I'm not a language designer, and I think there are limitations and things that don't really come to mind right now, but that definitely wouldn't work, essentially. That made it such that there are some things that were impossible. And I still think to this day, maybe someone more skilled and knowledgeable in the whole language design area could come up with something, but I believe that building a properly typed R would be, at the very least, extremely difficult, if not impossible. At least to me currently, with my level of skills and knowledge, it is absolutely impossible. Namely because of the R does a lot of funny stuff. The lazy loading, the lazy evaluation, the meta programming. You can change types at runtime anywhere. It seems to me very difficult. Handling time, like the built-in NAs is great for a statistician, but when you design this kind of system, it's very difficult. But so essentially, one train of thought led me in that direction, because I love types now. Since I can't remember which language I tried, I was typed But now anything typed, I try. I don't think I would ever learn another dynamically typed programming language. If you are watching this and you have never really tried a properly typed, strongly typed programming language, I encourage you to do so, and to do so kind of to give it a serious go. You realize you realize what types enable. They're genuinely not there just to help the compiler. They're really there to help the developer, but you in this case just as much. With typed languages, I have discovered, I've essentially discovered refactoring, which I think in R and other such languages you think you do, but you don't. I don't know where you draw the line. When is it that you stop refactoring and you start just rewriting stuff entirely? And in R, as you do so, at least personally, still to this day, is kind of stressful. It's not a pleasant thing to do, and I know it's not a me thing, it's the language. I've seen our programmers are vastly more experienced than I, approach refactoring with the same kind of levels of anxiety and caution. Whereas in a typed language, you see something you don't like, even if it's at the very core of what you build, and you just rip it apart, and you let the compiler or the LSP, whatever the parser, let you know what's broken, what you need to fix. And it's such a pleasant experience. It makes you much more at ease with your code. Now this started on Builder. This is Builder. Sadly, maybe in the future could enable types, but like I said, there are other problems. But so essentially, it led me to another thought. What led me essentially to Vapor was, I thought, just like in the world of JavaScript, you've got TypeScript. You can create a typed superset of the language, and that transpiles. You can write your code in TypeScript. It transpiles to JavaScript, but it gives you types in that dynamically typed programming language. But together with it, as I've done more JavaScript, there are other things actually that they have in the community that they're outside of the language that I know comes under a lot of criticism. I'd be the first to bash JavaScript, but the tooling is actually pretty interesting. I think the tooling is pretty interesting. All of these, although it's albeit a bit messy, but the idea that you can have like I don't know how they call it actually, bundlers, minifiers, uglifiers, they've got tons of, I think, words for it, or as I kind of think about it, preprocessors. So you have Vite, Rollup, Webpack, ESBuild, God knows what else. And this is interesting because then you have, it introduces multiple things. One of them is the distinction between the code you write and the code that's ultimately run, which is generally not a distinction you have in a dynamically typed programming language. Whether it's an R script, a Python script, a small JavaScript file, generally the code you write is the code that the user just runs, or the browser runs, or whatever the program runs. Here it's not the case because you introduce a build step, so to speak. So you're going to write your code in one file, then run a piece of software over that file, and let it do plenty of stuff. You control that, of course, but you can let it do plenty of stuff. And then it outputs another file, and that's the file that you kind of share with the rest of the world. And that to me is very interesting because technically, to some degree, we could say, I think that is what TypeScript does. It accepts TypeScript files and outputs JavaScript files. In the world of JavaScript, it's used for plenty of stuff. You might have heard of, even if you haven't written JavaScript, you might have heard of minification. A lot of the code we write in every language actually includes loads of syntactic sugar that is there, I'm not sure syntactic sugar is the right word, but include loads of stuff that's there. In the JavaScript world, I was saying, they have loads of, they do stuff, this minification thingy. And this idea of minification is, yes, in the code we write, there's loads of, I call syntactic sugar, I'm not sure it's the appropriate word. But there's loads of, I don't know, spaces, new lines, comments, stuff like that we add to help us developers. But the program itself, the engine, the language doesn't really need any of that. And so this what you can do with JavaScript, you can get rid of all of that to kind of squeeze the entire code into one line. That reduces the file size, makes it load faster in the browser, etc. And I think that's one of the kind of things, at least in the JavaScript world, that's sparked this idea of, separation and this build step. That, together with another interesting idea, which was I think it was Babel. You can write in your JavaScript code in the latest version of the syntax and then have it transpiled into an older version of JavaScript. The point of that being that the older the version, the more, in a sense, the more likely browsers would support it. You can't rely on your users having updated their browsers to the latest version and supporting whatever syntax you have in your JavaScript. And that, for instance, is something you could imagine for R. R, the syntax is very stable, I think. So there's little point in taking your code from today and transpiling it to R 2.5. Very little would change, although some of it could be interesting, like the native pipe that you would have to get rid of, replace for a Magritar pipe, stuff like that. But then you will see that some of these preprocessors can then, depends on the plugins they use, depends what you do, but they can do loads of stuff on your code. They can do tree shaking, that they remove dead code. They can do additional checks that you normally wouldn't do. They can do plenty of stuff, and that's essentially the idea behind Builder. Builder is a preprocessor for R. So again, you write your R code somewhere else, and then you transpile it to, well, it's more like a copy it over to R. If you think one of the things, convenient things you can do already, if you want to write an R package, well, Builder would let you in your source directory have however many subdirectories you want. It'll flatten that and output it in the R directory. But then you can start having more interesting things that you see you can do maybe with the syntax. For instance, f-strings. I call it f-strings. I think that's how it's called in Python, so people may be familiar with it. Oftentimes that's what I want to do, something like that, to concatenate strings or to build strings. And I know in R you can do exactly that with the glue package, which is brilliant, but I'm building large shiny applications for a living, things like that. I've already got enough dependencies. Even though I trust the reliability of glue, I just don't want to add that in because I want to play with just a handful of strings. It really doesn't make sense. So I can write that, and then Builder will go over it and generate this, which is quite neat, I think. And then something maybe a bit more interesting, you can say have pre-flights. Pre-flight is this code that will run at build time, but that will not make it into the output. So maybe you generally needs to check on conditions. Maybe I want to check that, I don't know, whoever needs to build this needs to have a specific environment variable set or something like that. I can run that and I don't know, handle it however I want. Depends. It's pretty much like your Roxygen 2 stuff, except this is our proper developer dependencies. They're not there in your description file. Users don't need it. It's just there for the developers. You can include, that I thought pretty interesting. You use the syntax. It's always a special comment. Include the type, the file path, and the variable. We support plenty of stuff, and the idea is, for example, you have a nice SQL query. That's a short. That's a bit of a weird. That's a small one. That's a very small one. But imagine it was a long one. You want that in an SQL file, and then you can include it like that. And at build time, it will expand to this. That's for an SQL file, but you can do that if you want a base64 encoded images. If you want a data frame that you've got as a CSV that you import like that, you can do plenty of stuff. I don't know, I'm not going to go through it all. You can do inline tests that will copy to your test ads. We have macros. That's pretty funny. It's a macro funny, I don't know. That's a pre word, but it's kind of a function, but then you will see that it expands to something so that it kind of copies the body of the function with some replacement. It's pretty fun. Tons of stuff, directives if you want to check stuff at build time, you can do dry runs, etc. So I probably did a port of explaining that. I'll re-record that later. Cheers.